Good afternoon. Today we talk about the geologic. It's a subject of this three. For this, in this case, we talk about rock mechanic. Our group, is composed by Juan, Camilo, Fajardo, Ángel, Nathalia, Muriel, Isabella, Narváez, Miguel, Ángel, and Dayan, Ordoñez. For this team, we talk about first an introduction. And in this case, we can talk about the rock mechanic is a relatively young discipline that emerged in the 1950s with the first apparition of this discipline. And or we talk about rock mechanic, we can talk first about rock in the singular significance. A rock is defined as an semi-solid material of natural origin present in the crust of a planet. It's viewed as a branch of geological, geotechnical, and civil engineering, aside from the need to better understand the energetic properties that rocks have in general and a given area, carrying out a theoretical and practical study of their properties and mechanical behavior of rocky materials and their response to the action the forces applied in their physical environment. In this case, we can see that the more important aspect of the rock mechanics is the physical environment because they influence direct of the comfort of the rocks. The purpose of rock mechanics is to know and predict the behavior of rocky materials before the action of internal and external forces that are exerted between them. In this case, we can see that internal and external forces is very important for the comportment of the rocks. And for this, we can study the physical environment because with the internal and external forces, it's the same because with this, we can generate. And with this, we can predict five principal problems that present of the geological environment, such as fractures in rock, scale effects, tensile strength, groundwater effect. And now we can generate an abstract for the presentation, and we can say that the rock mechanics is related to the study of response of different types of rock to an applied distributions called natural of engineering process. We can see in these pictures that the rocks take different forms: circular, rectangular, planar, and for this we can and we need a study for study the response of the. This topic has a lot of field of study where it encompasses in-depth and note of rocky materials. Rock mechanics are a base of the theoretical and practical study of the mechanical properties and behavior of rock materials and their response of the action of applied force in their physical environment. In this, we can see that each rock has different mechanical properties. For this, it is necessary to study this rock in punctual aspect, because the forces of the physical environment apply different for each rock. The purpose of rock mechanics is to know and predict the comfort of rock materials in the face of the actions of the internal and external forces exerted of them is the same. For each rock, we can know if we need a study that intervene different actions of internal and external, and the rock conform different. This discipline has several important applications that attribute in quiet as an civil engineering, mining, geology, and geological engineering as such. In this case, we can. Is the most important is civil engineering because with the future construction is the base of the aspect.
History. Rock machine emerged as discipline around 16th of the 20th century. This arose because of the need to look for concepts and theories of rock machines. which is why it was separate from the machines of soils, since this concept did not perfectly please the rock.
As my mate said, the rocks mechanic was founded in 1950 to give a differentiation between the rocks massive and the soils. That's because the rocks mechanics and the soils mechanics have different physical behaviors. In rocks mechanics exist two types of classification of rocks massives, the Chile and Diane. We say a rock massive is Chile when this is continuous, that means it doesn't have any presence of breakage. Homogeneous, that means all the components of the rock are the same in all the sections of the rocks. Isotropic, that means all the mechanical properties of the rock are the same in all the sections. For example, the thermical conductivity and the linearly elastic. Otherwise, we have the Dayan, who are the opposite of the Chile rock massive. We have a perfect example of a Chile rock massive, like the left one, like the picture of the left one, and a Diane rock massive, like the picture in the right side. The factors who are important to know about the rocks. The density. We can calculate the normal density, who are exposed in the diapositive. The dry density, if we want to calculate the dry density, we need to dry the rock massive, and the saturated density. If we want to calculate the saturated density, we need to drown the rock massive. To calculate the density, we need to know the mass and the volume of the rock. The witness. Witness is the person of wet who presents the rock. If we want to calculate it, we need to know the mass of water. If we want to know the mass of water, we need to lessen the mass of the rock, less dry mass of the rock. This between the dry mass of the rock and multiply by 100%. And saturation percent. The saturation percent is the quantity of water who is deposited in the pores. If we want to calculate this one, we need to know the volume of water, the volume of pores, and this multiply by 100%. And the last one is the velocity of propagation of ultrasonic wave. This one is one of the most important of the rocks massive, because this factor could simulate how is the behavior of the rock in the case of an internal seismic wave, for example, a P wave or an S wave. It depends on the quantity of pores of the rock massive. If the rock massive have a higher quantity of pores, the velocity of propagation will be similar like a P wave. And if the like an S wave. And if the quantity of pores are lower, the velocity of propagation will be similar like a P wave.
Applications in civil engineering. The rock mechanics has a great application in civil engineering since construction works such as bridges, tunnels, houses sometimes must be built on rocky terrain, and it is necessary to define the quality of these rocky terrains, define the type of foundation to use and the depth of this foundation. Rock mechanics, where its most important application is in the constructions of roads and tunnels, since the properties of the rocks must are analyzed in detail, and it is defined if it needs some type of support or coating. Rock mechanics are important in the stability of slopes on roads, since the angle of the slope cloud be defined to avoid collapses or rock slides, and it is also important in the construction for hydroelectric dams, where the quality of the rock massives must be defined, where the entire structure of the dam.
Rock mechanics are related to the study of the response of different types of rock to an applied disasters caused by natural or engineered process. Rock mechanics are the theoretical and applied science of mechanical rock behavior. It is generally profitable to conduct complicated and costly on-site testing for determining rock engineering parameters unless it is large project. The purpose of rock mechanics is to know and treat the comfort of rock materials in the face of the action of the internal and external force extended on them. The different areas of application of rock mechanics are ground into. One, when the rock material constitutes the structure, tunnel excavation, slopes. 2. When the rock is the support of the structures, foundation of buildings, dams. 3. When rocks are used as building materials, embankments, gabions, fillings. Knowledge of the stress and deformation that the rocky material can withstand under certain conditions allow to evaluate its mechanical behavior and address the design of the structure and engineering works. The relationship between the two parameters describe the behavior of the different types of rock and rock massive, which depend of the physical and mechanical properties of the material and the condition to which they are subject in nature.
Finally, about all the presentation, we can select important conclusions about this theme. First is that the view of rock mechanics as a branch of geological, geotechnical, and civil engineering starts from the need to better understand the engineering properties that rock have in general in a given area. In this case, because we can study civil engineering, we need to know about rock mechanics of the composite of each rocks. Performs a theoretical and practical study of the properties and mechanical behavior of rock materials, and responds to the action of the force applied in their physical environment. The same. We need the different physical environment and different forces that applied in each rock. That in the presentation, we can see that each rock can have different reactions of the environment, and for this it's necessary to study each rock that we can use in different construction and different aspects. In this case, on civil engineering. It seeks to know and predict the behavior of rocky materials before the action of internal and external forces that are exerted between them. The same. With this, we can know that is internal and external forces and we know the future conformant that the rock. And with this, we can prevent different problems. With this, it is possible to prevent mechanical problems presented in a geological environment. In this case, we can see that we talk about 5 more important problems that present the rock mechanic or the rock fractures. It's rock fractures, scale effects, tensile strength, groundwater, and phase and weather. It's the different problems that cause about the environment and the internal and external